Welcome back to Blockstream Talk. Today we're speaking with senior Lightning Network developer Rusty Russell, not only about all things Lightning, including Greenlight and XPay, but also about the Great Script Restoration, a proposal to make Bitcoin great again by re-enabling opcodes that Satoshi himself chopped early in Bitcoin's history. If you find the conversation useful, don't forget to like, subscribe, and share. Back by popular demand, Rusty Russell. Sir, how are you?
Good, I'm great. And thanks, Jesse.
So welcome to, I think this is your fourth appearance on Blockstream Talk.
Wow, already? Okay. Yeah, I'll go with that. That's good.
All right. So to start off with an introduction to anyone who hasn't seen any of your previous appearances, how did you get into Bitcoin and how did you end up in Blockstream and working on Lightning?
Wow, Bitcoin. I came in from a tech angle. I've always been a developer. Bitcoin was this interesting kind of open source experiment in trying to make money, make money for the internet. And so I came in through that path. I've been at Blockstream now almost 10 years, like 9.5 years. And all that time pretty much working on Lightning. So that was the beginning of that journey. So I guess that's like my canned history of where I got in. It's kind of been continual refinement on the Lightning Network. Since then. So I guess that's my background.
Okay, great. One of the first things I wanted to ask you about was the Great Script Restoration Project. Can you give an introduction to that? What is the idea there and what are you trying to achieve?
Yeah, okay. So people have been talking about making enhancements for script, well, since forever. But there's a number of proposals at the moment, some of which are quite exciting. They do kind of niche things, extend script for a specific use case. But when we look back, in early 2010, Satoshi actually went through and disabled a whole pile of things that were in script because they were too powerful. There was no limits on what you could do. There was kind of no accounting. And so basically, Bitcoin has a scripting language inside it. You can specify, if you control the UTXO, you can specify the conditions under which it's spent. Not just, hey, you have to sign with this key, which is the normal one. But, you could write these little programs that could specify all these things. It was, really, really powerful. And it comes from the idea of programmable money, which predates Bitcoin. It's like this idea that the network itself would enforce your will. You would say, hey, these coins can be spent under these conditions, and it would do whatever you could imagine writing conditions for. But Satoshi unfortunately had to go through and, when someone discovered that there was a huge issue with this, had to go through and basically rip a whole heap of them out and truncate them and basically just kind of amputate at that point. This is kind of an emergency fashion when Bitcoin was very young. So the question is, when people are talking about extending it again, first thing you come back and, hey, maybe we should finish that job, right? Satoshi kind of he did what he had to do to amputate, right? But you're like, well, can we do that safely? Can we restore script in a way that, obviously contains the risks that, that was the problem that had to be disabled in the first place. But now we're not in a panic situation. Can we do it in a way that's reasonable? And that's basically what Great Script Restoration is, giving us back the script that we kind of originally had in Bitcoin. And of course, in the intervening years, a lot of people have come up with a lot of novel, powerful things they could do if only script hadn't been kind of, truncated like this. So when I look at people going, hey, I really want to do this with script and things like that, I go, well, if we'd had that back originally, that would have been really good. Now, it's not to say there aren't some other things that could definitely be improved, but I kind of want to start from, well, let's bring script back to the powerful thing that originally was, and then go, right, what else can we do from there?
What was the reason for Satoshi's amputation? Was it because it must have been security concerns, right?
It was security. So, for example, you could write a program that says, hey, take something on this, take something, copy it, and join them together. That's fine the first few times you do it, but you keep doing that and it keeps doubling, right? There was no limit. You could keep doing that, and then everyone's machine blows up, right? You couldn't evaluate the transaction. So there were really, the code was very, very simple as the good side. The bad side is it didn't have any controls. And there was a pile of things Satoshi just went through and went, wow, okay, any of these that look even vaguely like they could contribute to this kind of problem that he had just been made aware of, had to go. And so he just soft-forked out a whole heap of things just no longer worked, which absolutely is the right call. I mean, I've been in that kind of situation before when you're like, wow, if anyone finds out about this, the whole thing's going to blow up. Bitcoin's 1 year old. You're like, well, the most important thing is that the network stays up, right? So 0.3.1 of Bitcoin came out, and it had all these, these opcodes simply truncated or removed. It used to have arbitrary length. He said, okay, you can only have small numbers now, and all these things were constrained in a very hasty way, just to make sure that this couldn't happen.
And what has been the feedback on that since you kind of first mentioned that at BTC++ in Austin?
Generally pretty good. I mean, people are like, well, see, this kind of feel like a bit, as a developer, it feels a bit like unfinished business, It's kind of like, the kitchen was on fire, so we kind of we put out the fire, right? But now we've got this water damage. We've just roped it off and gone, don't go there. So, well, we didn't really finish the job. We should finish what Satoshi started and restore things in a way that's obviously safe. So that's what Great Script Restoration is about. And there are a number of things that we've done in the time since then that shows us how to do this in a pretty safe way.
Okay. Does that conflict at all? The idea of sidechains, one of the big kind of use cases is that you can do more innovative things on the sidechains and not touch the main chain as much, because now Bitcoin is a very valuable asset with, it's a lot more risky now than it would have been 10 years ago.
Well, there's two things there. Yes, one, some of these things are already on Liquid, right? So Liquid has a whole heap of additions, which somewhat go back to restoring what Satoshi did. Although with this, we're talking about like a sweep through and basically trying to bring it back to the way it was, which is a different approach. Rather than adding on things, we just basically go, cool, well, these are all restored, which is kind of a simpler roadmap in a way. We're just going to bring back whatever else. Now, it's possible there's a soft fork at the same time, which adds extra things that we definitely want. But, that would be the minimal bar. As for risk, on the other hand, things are a lot more considered now. We have a lot more testing. We have a lot more developers. We have a lot more people looking at the code. Definitely the stakes are higher, but our capability to do these things is also a lot higher. So it's certainly not out of the realm of possibility. If you think about early computers, right? The first computers were not programmable, right? They did a specific task, right? They did one thing. The revolution, the real breakthrough, was programmable computers. The person who built the computer didn't know what you were going to use it for. They gave it to you, and you could basically build. You don't build a computer these days and go, well, I'm building this one computer to play, the latest computer game, right? The game may not exist when you build a computer. The innovation is that it's programmable, and this was one of the innovations in Bitcoin. I didn't quite reach that promise because of this CVE issue. And people ask, what's it for? And I'm kind of like, well, it's hard to describe. The same way any problem I could describe, you go, well, we could just add an opcode that does that. And that is true. But history has shown us that these things are most powerful when you create the platform that people can build on, and then they go off and build their own things. And I think there's almost an ethical responsibility that if you have a UTXO, you should be able to dictate how that is used. In as powerful and simple a way as we can make it happen, in a way that doesn't obviously jeopardize the entire network. So, I think it's almost like, well, this is what Bitcoin should be in many people's minds. So I think there is a drive to do it.
Yeah, it's kind of interesting how it's developed. I think people are probably happy with number go up and how the price moves, but I think there are definitely some centralization concerns when you see people like BlackRock, you see all the ETFs. The ETFs themselves are massively centralized. You see MicroStrategy, you see Coinbase holding all the coins for these. The way it's developed is kind of in some ways, there's definitely a strong centralization trend to what's going on the Wall Street side.
Yes, and to some extent, they didn't need a lot of the features of Bitcoin to get there, right? We could have had no script in Bitcoin at all. We could have had single signature. That's enough. You could have had a minimum viable. You could imagine a minimum viable Bitcoin where I can send you Bitcoin, you can send it to me. That's all it does. No Lightning, no nothing. That probably that could well have led onto the same trajectory at this point. But I think those other things are going to be increasingly important, right? Lightning is enabled by scripts, even though Satoshi Lightning didn't exist when Satoshi wrote script, right? So my experience has led me to strongly support the idea that if you build these things, then clever people will come up with great things to do in future, and I want to enable that.
Yeah, I think that's a fair comment on how it could have come to the same point, because I don't think that Wall Street, they're not looking at anything beyond fixed supply. Really at all. It's the idea of digital, peer-to-peer digital cash is not on their radar at all. Censorship resistance isn't even on their radar at all. So they're basically just looking at this one thing. So that's So what would this process look like for the activation of something like the great script restoration? Well, how would that work?
So to even get to the point where you're talking about activating something, right? You need at least three things. It needs to be a good idea. It needs to be something that that we go, cool. This is useful. This is something we want. That's the first thing. Secondly, you've got to make sure it's not something we'll regret later due to obsolescence, right? There's some steps where you go, oh, we could do this now, but if we're going to do something else later, or if it doesn't work when fees go up, for example, that would be the classic thing. You'd go, well, that might look okay today, but I think that's going to look, we're going to want something else down the road. Now, to some extent, the perfect is the enemy of the good, but if you know it's going to be obsoleted, that's also a blocker. So it has to be something we're not going to regret putting in later, because we never get to remove things in Bitcoin. Right? Doing that would potentially confiscate people's coins, so you can't do it. So once you've done it, you got to stuck with it. And second, and the third requirement before you even talk about activation is it has to be absolutely be the best thing we're aware of. And you only do that by people coming up with alternatives and differences, and you build up a canonical suite of ideas. How else could we do this? Is there a better way of doing it? What are the disadvantages of all the other ways of doing it? You kind of build your proposal on the bones of all the proposals that you killed, right? So you really do, that just takes time and effort. And, it takes really smart people thinking really hard about it and then going, hey, I have an idea. We could do it this way instead. And that you have to figure out what is the absolute best. Once you feel that you've got something that's useful, that you're not going to regret later, and that to the very best of your ability, of your knowledge, is the optimal solution, right? That there isn't something else in the wings that's going to obsolete it. At that point, you can start talking about activation. At that point, you go, cool. Now it's a matter of we're convinced we want it in. It is useful. It's the best it can be, and then we can talk about these things. But there are always that just takes time. You've got to make sure that everyone has thought really hard about whether this really is the best thing. There have been things that have been put into Bitcoin before, and in retrospect, like, oh, we could have done better. But now we're stuck with them. So we really want to make sure that happens, and that's going to take time. And there's something about chicken and egg, right? Unless it looks like it's going to potentially go in, most people are not going to pay any attention. And then when you've got to cross that line. They go, okay, so it is going to go in. Now I'm going to go and I'm going to read it. I'm going to think really hard about it. I'm going to look at alternatives and all those things. And that it just takes years. And there are more people in Bitcoin now. You can't just get 5 people in a room and go, cool, this is the best idea, which is great. But it is going to take time.
The last fork was more of a retail audience. If we this would require a fork, right? And maybe you can explain quickly, because there might be some people these children of summer who haven't gone through a Bitcoin fork war. Can you explain what a soft fork and a hard fork is? Okay,
so a soft fork is what we do in Bitcoin, and that is that we make rule changes that are backwards compatible. So if you don't upgrade, your client will continue as normal. You won't be able to use the new thing. That's fine, but you won't get upset about other people using it, basically. And that's how we work, right?
People will still get upset. Yeah,
it's really important. There are a whole heap of things in Bitcoin that are legal but nonsensical. You kind of well, I don't know what that means, but it's okay. And that's where we put the new stuff in, right? So that then gets a meaning assigned to it. You go, cool. Well, if you do this, then there's this new rule. And the old nodes go, well, I don't understand it, but it's okay. The new nodes are actually checking it. And that's how we ensure backwards compatibility. And frankly, the minimum of duress in the network, right? There's no forced upgrade on anyone. And that's an important principle, right? If you had the power to force an upgrade, then you had the power to force a bad upgrade. So that's also the reason why these things take so long. It requires everyone to move. Everyone's got to agree pretty much to get this process going. So, it's just slow, and that's okay because if it fails, then Bitcoin just doesn't get better, but it doesn't get worse. It doesn't stop. It doesn't break Bitcoin. If we have a fantastic change, it doesn't get in.
Because you've got an alternative. Yeah,
that's right. So that frankly, in money, that's a property you want. That if people can't agree, it doesn't break.
Yeah. So, that's what happened with the block size war, right? Is that some people wanted bigger blocks, some people wanted to leave it kind of the way it was. And then we get two camps that split off, and we get some people that are, still complaining on Tucker Carlson about the way that went, many years later. Yeah, look, people obviously get really upset about these issues. And to be fair, the first major crisis that a project has is always kind of formative, right?
It always seems like a huge storm in a teacup at a time, but it does set certain principles. I've been through this with almost every project where you've got something, and something crisis comes up. Somebody wants to fork the project, do something else, whatever else. And it seems like a huge deal at the time, but in fact, it's a requirement for almost any project to learn, right? And go, okay, so what is the process by which one makes change? And how do you tell that it's not working? Now, in that case, the change they were requiring was a hard fork. And that is not a backwards compatible change. That requires universal adoption. We have not had one of those in Bitcoin, certainly not in modern Bitcoin. We can argue about some of the early stuff, but really, that is I think a much higher bar to start with, right? Just, there is some sense of duress, right? If you don't agree with the hard fork, you're going to get stuck. So you've kind of got to upgrade. And that is a very different deal. We would do it absolutely if we had universal agreement on something, but so far we haven't had to. And it would have to be, okay. There's going to be a hard fork in Bitcoin simply because at 2138 or something, our timestamps will stop. And we need to change the rule on that because we literally couldn't produce blocks. So, sometime in the next 100 years, we are going to need a slight modification to the rules to allow that number to wrap around again. So that's a hard fork technically because the old clients will stop at that point, but they don't have a choice. They will literally get to the last block and go, well, we can't go any higher. So I think it'll be non-controversial, but we've got a good few decades. I will be long dead by the time that becomes a hot issue, I think. So
someone else's problem.
That's right. Maybe my grandchildren or something.
That's right. So why would that even be there? Why would it time out why would there be that limit on it? Was that an oversight or?
Well, designing software for 10 years in the future is hard. Designing it for 100 years in the future is even harder. It's fairly easy to fix. You just do a subtraction. You go, well, if it's wrapped, then obviously it's wrapped. That's fine. Yeah. We do the subtraction. At the moment, it goes, you have to be greater than the last one. Well, at some point, you get to the last one. Well, how do you do that, right? The timestamp on the block gets to a certain number, and you're like, well, the next timestamp has to be one more. Like, well, you can't be one more because you're literally on like 9999. It's not actually 99, but you get the idea, right? And so you got to change the rule and go, okay, well, if it's less than the previous one, then you do the subtraction and go, okay, it's overflowed, therefore it is greater than, right? But that's a rule change, and it's backwards incompatible. That's the only one we know about. That's in the next millennium anyway. So, it is an easy change. We have not made it because technically it would be a hard fork. But it's not controversial anyway, right?
Sure.
It is a purely technical detail that nobody really cares about. But it's worth a caveat there. We are going to have one hard fork in Bitcoin's existence, at least.
That's the clip. Let's prepare this clip. There is going to be a hard fork. Freak everybody out. We gotcha. Yeah. Well, so how would the Great Script Restoration? I know you've so I think it sets it up for more innovation. But can you think, specifically how would it change the way we interact with the network, kind of in the long run? Just generally the idea that we could have more innovation, or is there anything else you can kind of add to that? That's
a really good question. I mean, when you look at it at the low level, you're kind of describing all the trees, and it is kind of a foundation for other things, right? There are a whole heap of things that people now want to do. Our understanding is increased. We want covenants. We want ability to specify in more detail exactly how you can spend some funds for things like vaults, where you can go, cool, you can spend it, but there's got to be delay in there. So if something goes wrong, I can claw the funds back, right? That you create these vaults. We have extensions to Lightning like L2, where we want to have multi-party channels, and that requires modification. So there are all these concrete things that you can build on top. Now, you can build them just with Great Script Restoration, but there are also other opcodes that people have proposed. And they make more sense if you go, well, let's restore script first and then see what else we need, rather than just going, well, here's an opcode to do this one particular thing, and here's an opcode to do this one particular thing. We go, well, let's make script as powerful as we can, bring it back to its full glory, and then go, right, do we still need this new opcode, this new improvement? And I'm hoping that, with a couple of exceptions for things like Merkle trees and things that we've added, and Schnorr signatures in Bitcoin that we've added since the very early days, when we've restored script, we'll then be having debates about efficiency. That will be it. Someone wants to add new opcode. It'll be like, well, you can do it today, but look how big it is. People are doing this, and it's using up all this chain space. We could make that more efficient by adding a specific use case for that. And that's a very concrete discussion, right? You might be going, well, I don't care. They're doing this thing. They're doing this complicated vault thing. I don't use complicated vaults. But you still care because they're using block space, right? And the less block space they use, the more efficient the network is, the more block space is left for the rest of us. So even if you would never use this thing that people are using, you can look at it, you can run actual numbers and go, hey, 30% of our block space is taken up with this thing. If we have this new opcode, that drops to like 4%. Okay, that's just more efficient. It's a much more informed discussion on future forks. So once we get to the point where you can do what you want, then we're just debating over efficiencies. And it takes some of the heat out, right? If people really want to do something, they can go and do it. And then you're just arguing, well, a lot of people seem to be doing that. Let's make it better.
Does that mean that you could do more stuff on chain that you now have to do on layer 2s? So what does that mean for Liquid? Would there be less of a use case for doing stuff on Liquid if you could do stuff directly? No.
No, what it actually means is that you can build more sophisticated bridges to layer 2s, right? And that is useful. But Liquid, I mean, in theory, yes, you could do some of the things that Liquid does. For example, confidential assets, where you can't tell the amounts or exactly what asset is being transferred. That is a big lift for Bitcoin. And it's a big lift for Bitcoin because even if we figured out a way to do it we could probably do it using script and crypto, all this stuff, right? Unless we come up with some revolutionary way of doing it. Those transactions are bigger, and they will be expensive on Bitcoin. They will also take an average of 10 minutes, whereas Liquid is like 1 minute blocks like clockwork, right? So it's like waiting for a bus that comes every minute. Your average wait time is going to be 30 seconds. That's pretty good. And it's pretty predictable, right? So there will still be a definite use case for Liquid as it is. But some other things, there are definitely things that we could start doing on chain. But most of the excitement is in the layer 2s that we could build and the more efficient layer 2s we could build, whether it be ARC, whether it be other enhancements that people have proposed, timeout trees, a whole pile of different changes, including better Lightning, multi-party Lightning. Instead of just you and me having a channel, we have this collaborative thing which we can spend out of. So, there are definitely things that we want to build.
Okay, shifting gears to Lightning, I think that's a good segue. One of the big milestones of 2024 was dual funding. Can you talk a bit about why that's important and how it benefits the network, the Lightning network?
Yeah, when we first specified it, single funding, so just one side puts all the money in, it was just a shortcut, right? It was much easier. With dual funding, it's a negotiation process, right? So we basically collaboratively produce this transaction that's going to fund the channel. So I can go, well, I'm going to throw some funds in. I'm going to throw some funds in. I want my change to go out here, and or even I'm going to actually open two channels at once. I'm negotiating with you, but I'm also negotiating with someone else, and I'm kind of crossing those over. So this whole negotiation protocol does a couple of things. It makes chain usage more efficient, but it also provides a marketplace for channel funding, which is pretty interesting. So I can say, hey, I will fund a channel for you, and it's called liquidity advertisements, where we put these liquidity ads out on the network. Say, hey, here's my rates, right? I'll fund a channel for you for this period of time. And here's how much it'll cost you, like a base plus percentage kind of deal. And that's kind of interesting from like a marketplace point of view. The other thing that's interesting is that negotiation, because previously you just went, I'll open a channel with you. Where do you want what's your keys? I'll figure it out. And I create the transaction by myself. Because we had to have a protocol for negotiating. Okay, so we want to send it here and I'm going to put this in. You go, I'm going to put this in, and we sort it all out. That same protocol is useful for splicing, which is basically taking funds out of a live channel or putting more funds into a live channel, where we do the same kind of negotiation. We go, cool. Obviously, we're going to spend the channel. We're going to put something back into the channel, but I also want to put more funds in. Maybe I want to have some change that goes out, all those things. And we both collaborate again. And it's the same protocol. So the thing that we use for dual funding also basically enabled splicing.
Bolt12 was a game-changing update this year. Can you give us some insight into where Bolt12 came from, what it does, and the process of merging it into the Lightning spec?
Bolt12 was a long-standing idea after we saw Bolt11, the original payment format, in real-world usage, right? We saw how people were using it and abusing it, and we thought, well, we can build something better. And this was proposed 5 years ago at the Lightning conference in Berlin. And it's been refined ever since. It uses the Lightning Network itself to fetch the invoice, a little bit like LNURL does this over HTTP, but this is actually Lightning native. And using Lightning native means that we can You have end-to-end assurance that the offer and the final payment are fully linked. And you can build much better UX because of this. And Bolt12 is in fact extensible. So there are some enhancements that will be coming to Bolt12 as well that I'm pretty excited about.
Can you expand a bit more on how the spec process works for things like dual funding?
Right. So yeah, the spec process is a collaboration between all the different developers of the different implementations. I originally chaired the spec process, but now it's a rotating chair, which is amazing because it's a lot of work. And we all kind of talk about, oh, here's what we want to do. To get something into the spec, you have to have two separate independent implementations. So you write it up in the spec, you go, here's how we should do it. Someone else comes along, they do it too. You test that you work together. That's the concrete test that the specifications written fairly well. It also gives them a chance to go, hey, maybe we should do it this way instead, right? There's a lot of back and forth that happens in that stage. On the core Lightning side, we always introduce things as experimental first. If they have not been finalized in the spec, they're always an experimental feature. We only flip it to on by default once it is formally adopted into the specification. So we will roll out experimental things, but we will always, you have to enable them. So people, you're feeling brave, you turn them on, knowing that the next version it might completely break, right? Because it's not spec final, right? We know there's a negotiation going on about the details. So in this case, it was Eclair, the async, and us doing the dual funding and in fact the splicing work to make sure that we interoperate. So yeah, that tends to be the way it goes, and it's a great example of collaboration between the different teams.
Oh, wait, great. Another interesting product from Blockstream is Greenlight, headed by Christian Decker. So I was talking to Jesse J earlier. He says that it's got 150,000 nodes online now, which is a pretty amazing accomplishment. Can you talk a bit about Greenlight and maybe first let everyone know what it is and kind of what the developments and progress have been with Greenlight over the, I guess it's been 6 months or 8 months since we've talked to Christian?
Yeah, absolutely. So it comes back to Blockstream's motto, which is don't trust, verify, right? For a long time, I'm actually wearing the t-shirt. I'm wearing my old green wallet t-shirt. This is one of the first things that came out that was actually bought by Blockstream, was this wallet that allows you to do two-factor authentication and everything else because it signs off on transactions, but it doesn't control the funds in any way. So Green is a great example of, we help the user, we give them a lot of assistance, but we can't spend their funds. And we can't even confiscate their funds, right? Because they always time out back to their single signature. So it takes two signatures, Green's and yours. Right? And our question was, can we do a similar thing for Green for Lightning, right? We don't want you to have to trust us with your funds, but you want us to do hosting and sort these things out. And so Christian came up with this architecture that became Greenlight that basically means we run the Lightning node for you, but whenever we need someone to sign for you, we call back out and go, hey, can you sign this? And you go, yes or no. Right. So when you put a commit, you go, cool, send this money. It calls back out and goes, cool, will you sign this? You go, yes, we will. Right. So there are a lot of parts to this. The VLS project is one that I have particularly to shout out to, which basically is a signer for Lightning that makes these decisions. Right. Should I be signing this? Is this valid? Can you prove that this is okay? And they did a lot of the heavy lifting on that side. Greenlight itself is basically now a hosted solution. So we will host your Lightning node for you, but we have no control of your funds. There's a bit of a compromise here. I mean, we can see what you're doing most of the time because we're actually running the node, which is good and bad, right? It's good for debugging. It's great for us because we can see what users are doing and we can go, this payment's failing a lot. What do we do about that? But one of the features of Greenlight that we've insisted on, that's really important, is that you can always take that on-prem later on, right? You can take your core Lightning node off Greenlight and host it yourself. You've got the keys. It's that easy.
What about interactions between Bitcoin's two main Layer-2s, right? So Liquid and Lightning. That's been another big development of the past year or so. Absolutely.
We've seen, if you go back to the original Liquid paper, there was the talk of atomic swaps, right? That one way to get, because pegging in and pegging out through the network was going to take 100 blocks and everything else. And there was but we can do atomic swaps. So people could provide these swaps much faster than this. And that is Lightning. Lightning is a series of atomic swaps. So even from the very early days of the Liquid network, it was obvious that there was this synergy between this atomic swap network and and getting money in and out of Liquid. Now, Lightning could always theoretically work on other networks, and Bitcoin's obviously the most important. But Liquid's a federation, and so that comes with trade-offs. But one advantage is the 60-second block times and lower fees. So you can argue that it makes Lightning less necessary there, but it also makes Lightning more powerful. If you're prepared for the trade-offs, you can do cheaper channel opens and cheaper channel balancing if you have to push funds on chain and things like that. So this providers doing swapping and offering Lightning channels through Liquid is something that we've definitely seen increase, and I expect that to increase more as fee pressure goes up, which is generally the vector over time on the Bitcoin network.
Okay, back to the latest release of Core Lightning, the team shipped the XPay plugin. Can you share where the need from that came from and what it does?
Yeah, so it's really interesting. You mentioned kind of what did we get from Greenlight, and I alluded to this earlier. When we look back at the early days of Core Lightning, one of the things that Blockstream did is we had the Blockstream store, which was one of the early Lightning nodes taking real money for goods and services, right? So we got quite good at the mechanics of doing that. What it didn't do very often is actually make payments, right? Along comes Greenlight, and our users mainly what they're doing is making payments, right? And that was a pain point. It was very clear that for early on from the Greenlight experience, that making payments was the main frustrating pain point for a lot of people. So what happened in sort of Q3, Q4 this year, I myself just basically stopped working on everything else and made this my priority, right? And there was a whole pile of things that we did to try to make a new payment system that was as advanced and robust as we could make it. And the result is XPay. But first we did we had this a while ago, but there's this idea that when we first did Bitcoin payments, you simply made a single payment. But early on, we realized that we're more powerful if we can allow split payments across the network, multi-part payments as they're called, for obvious reasons. But it turns out that actually the way to figure out in an arbitrary network how to split a payment is a problem called min-cost flow. And it's a fairly complicated problem, but it's very well understood in the academia. So what's the minimum cost flow through this network, given that you could go multiple directions, right? We had a minimum cost flow solver that someone had written, and we ended up extracting that into its own plugin called Ask Renee. And the idea with Ask Renee is it would be the arbiter of all these things. It would keep knowledge of the network. You would feed it back results and, hey, I've discovered I made a payment through here, or a payment failed through here. It would keep all that data. It would keep multiple things going on at once and go, cool, well, we've got capacity here to make the payment, but someone's already making the payment right now. So do that juggling. All that complexity was moved into a new plugin called Ask Renee, named after Renee Picard, who did the min-cost flow and a lot of other really influential work on the Lightning Network, particularly on the academic side. So we shifted into Ask Renee. We rewrote a lot of our plugin infrastructure because XPay is quite a complicated plugin, and we added those. We added a completely new API to make payments called Inject Payment Onion, because we had a payment API, but once we added the ability to make payments to yourself, and blinded paths and other complicated things, that API started to look a little bit creaky. So we have a brand new API for that. And then one of the things that I'm quite proud of is that we took the Gossip network, the Bitcoin network, the Lightning Network as it is today, and came up with a compression scheme that threw away all the details except who was connected to who and how big those channels were, and compressed it right down to like half a megabyte. It's about 70. On a good day, 100 odd megabytes, right? That's a bit big to kind of test on regularly. So we had this compressor. And then we wrote a simulator that could, instead of talking to a real peer, you talk to the simulator. And it would, fake up the entire network for you with latencies and everything else. And that allowed us to actually do real testing on an arbitrary network. Go, cool, okay. I took my node on the network, found out where it was in the list, and went, cool. I'm going to try to pay the top 100 nodes because that should just work, right? And tune things based on what our success rate was that, right? Randomly put blocks and stuff in the network and channels are depleted and everything else. And how fast does it retry? How well does it learn from doing this? What if it gives me, it goes, okay, I can pay it. And I go, cool. Can you do that for 1 millisat less, please? How hard can I push this and really drive it? We learned a lot of really useful things from that exercise. But it gave us confidence that, well, at least my node will be able to pay pretty well using XPay. So on top of all this infrastructure, we then wrote XPay, which was relatively straightforward, to replace Pay, because Pay itself has a specific API, and we didn't want to be necessarily bound to that. But one thing I did do at the last minute is add an option for those who are feeling really brave, called, it's basically a takeover option. It says XPay, if I say Pay, you just steal that and try using XPay instead. Just transparently do it. It didn't handle all the cases. It handled, the simplest ones. You just say Pay this. But if you added some of the options, it punted and went, I'm just going to let Pay handle that. Now, what was interesting is that has proven to be incredibly popular. People have turned that on. So we're about to do a point release to fix some of the things and let it take over more of those payments, because people have been really enthusiastic for this, and they've just turned on XPay everywhere where I did not expect them to. So it's like, okay, cool. We will cover more of those cases of common arguments that people use, more information on things like this. So there's actually a minor release coming out, which fixes a number of XPay. And the most embarrassing thing is XPay actually doesn't pay properly across local unannounced channels. It somehow slipped through testing, and it fails if it's an unannounced channel. That was my fault. So we're fixing that too. So there's most of the feedback we've gotten on the new release has been from people really banging on XPay. So it's fantastic. It's great to see it popular. We've got some really good feedback from people. So yeah, there's going to be a number of more tweaks, and I'm hoping that we will get that out imminently. Probably by the time you hear this, there'll be a point release. And if I were you, I would jump straight to that point release, because XPay is going to be a level up. It was put in as an experiment this time, but given how strongly it's been adopted, I anticipate that it will be a first-class citizen in the next release.
Well, that's very cool. So it sounds like there's a lot of moving parts, and how, like, I imagine the core Lightning and the people contributing to it, I imagine that's grown quite a bit over the past couple of years. How has that changed over the years that you've been, working on Lightning?
Yeah, absolutely. We've this year, we've had 106 contributors, and 706 commitments at least. Definitely some of that has come out through our bounty program. We have a bounty program for particularly that people love if they're first timers going in and go, hey, here's a little thing that I can fix. That's been really powerful in bringing new people on board. The ecosystem itself is growing. More people are interested in doing these things, or they're users who just they're maybe semi-technical, they have an itch to scratch. But even things like documentation and fixes like that are always welcome. Somebody says, hey, I noticed there's a typo in the documentation. Great. You send that in and we'll fix it. Or our documentation has been rapidly improving. One of the things Shahana did in the last 2 releases is automate generation of examples. So they are up to date because we've literally generated them as part of the release process, so that they are legitimate. What would happen sometimes previously is people would put an example in, but other things would change. And the worst the only thing worse than no documentation is documentation that's wrong. So that has definitely been stepping up. And we've seen a lot more people contributing across the board on things. But the other thing, of course, is Core Lightning has an ecosystem of plugins that people write. And, those plugins, unlike the core, are written in Rust, they're written in Python, they're written in much more accessible languages, and a very simple API that they have to obey. And, a lot of the excitement is then out in the plugins that people write for particular things. So, that definitely has happened as well. So there's growth not just in Core Lightning and the contributors, but people building things on top of Core Lightning.
And is that how you see the evolution of these open source contributions moving forward? Is it people building more stuff in and around it?
Yeah, absolutely. At the moment, for example, Greenlight doesn't allow you to bring your own plugins, but we're looking at different mechanisms by which we could do that. And that opens up, obviously, then you've got those 150,000 nodes potentially using your plugin as it matures. At the moment, we restrict what you can do, but there's definitely more things. There are some interesting. Look, there is the sky's the limit almost in different plugins that you could write for Core Lightning. A lot of them end up getting folded back in. In fact, XPay, and I've got a shout out to this. Michael of Bolts actually got so frustrated with our Pay plugin, he wrote his own one called MPay. Right? It was very simple. It was very dumb, but it worked really well. And that was one of the things that lit a fire under me to go, well, if somebody can literally create like the simplest, dumbest Pay plugin that they could think of almost, and it works better than our Pay plugin, then we've got a problem. We need to reassess. So, that was very much, and splitting out the route finding was partially a nod to MPay, because if he wants to continue using MPay, then he could go, well, I could use my own thing, or I could ask ask Rene for routes and potentially use that. So get some of these improvements and stick with his own thing. I would always encourage people to try writing their own things. Most of the stuff that ships with Core Lightning is in fact a plugin. So if you want to create your own boutique version, then at the very least you'll learn a lot doing it, and possibly you'll find a bug in our stuff because hey, I produced something that's better. Great.
So you've got a long history of working on open source projects. How do open source projects find more contributors? Is there anything you can actively do to encourage more contributors, or is it just you build cool stuff and that resonates with people and they kind of organically find their way to you, and it's just kind of a matter of time and having cool stuff for them to work on?
That is really a really good question. I think there's some amount of organic growth that happens. A project has to be exciting, right? Basically, the more users you have, the more likely you are that some of them will get sucked across that boundary and become developers. Either they're developers already, or they grow up. They go, they start going, well, what happens if I change this, right? And if it doesn't work, they don't need to tell anyone. They bury it in the backyard, and you never find out. But sometimes they, hey, I changed this, and it made it better, right? Wow, this is amazing, and that starts them on a journey of contributing to this stuff. As the industry grows as well, it doesn't hurt that there are people who will pay you to do this stuff, right? You don't just have to be a unemployed a student with procrastinating student with time on your hands. You can actually go, well, I could actually make a living doing this, and that's definitely a draw as well. And we're seeing that.
Yeah, for sure. I mean that's what. So there's a lot more Ethereum developers, or there has been historically. Than it just seems like there's a ton of Ethereum developers that drives integrations kind of everywhere. And I guess that was the pull for the developers, was there's a lot of flexibility, there's a lot of opportunity to innovate and break things, and and I think that looks to me like some of that is reversing. We see more people interested in Liquid and looking at it as a solution for tokenized securities and stuff like that. So do you see people, some of those contributors coming from a background in other protocols and other chains, and they want to come and work on Bitcoin stuff, given that there's an opportunity to do more interesting stuff now?
Yeah, that's an interesting question. Actually, most of the developers we see come from different backgrounds, right? We don't see them so much from the crypto side. We see them from, just more intellectually curious, or they're just, they're new to the space altogether, which I think is healthy, because I think for a while there was certainly a taint around Bitcoin as in the open source world. Certainly, it was the weird scammy cousin of most of the projects. I'm paraphrasing, but certainly my kernel colleagues, when I switched careers and went, I'm going to go work on Bitcoin, they assumed that I was having some kind of weird midlife crisis, right? That I was, going to be, driving a sports car and, maybe I was, but I think there was definitely a miasma of some of the crypto altcoin, crapcoin kind of scammy noise in the ecosystem, which insulated them from seeing what Bitcoin is, and perhaps meant that they didn't understand it on the same level. That has not completely evaporated for sure, but Bitcoin as a story by itself is now becoming a thing. And somewhat fixing that, so people don't feel like, oh, it has this association with all these things. They're starting to think, hey, this is actually a positive technology that's really fascinating, and it's okay to be Bitcoin curious. So I think we're seeing more people come from that side, which I think is good.
So that's amazing. Do you think that stigma is still out here? Because when I was at the bank and we were having, I was trying to push people to do stuff with Bitcoin, I had one guy tell me, I'm not putting my name next. This is 2016 though. I won't put my name against anything to do with Bitcoin. And back then, fair enough, right? There wasn't as much information on it. There was, it wasn't as big as it is today. But you have, even the U.S. talking about a strategic Bitcoin reserve. Who knows if that will actually happen? But there's a lot more kind of a positive vibes around Bitcoin. It seems a lot more. Is there still stigma out there?
I think there still is, but I definitely see there is a sea change, this gradual change of you can ignore it the first 3 times, but eventually it comes back and you're like, okay, well, this is a real thing. There's definitely a stigma. There's definitely some stiction, right? It depends on, so to be fair, scammers are always asking you to reassess, right? You look at something, oh, this sounds really cool. Actually, it's a scam. Once you've made that decision, you optimize and you no longer reassess, because scammers are always like, no, we're not, no, maybe he's Craig Wright this time, right? You don't need to reassess. I've made my decision. I do not need to revisit. And that gets misapplied to Bitcoin. But I've been through this before. I've been through this in the Linux days when people were like, I'm not running this hippie operating system, right? I'm going to stick with tried and true. And you know what? Eventually those people retired. That's really what happened. right? They had this impression. So look, some of them learned, but some of them, it just took time. Younger people who had a different experience, who were much more comfortable with the new technology, rose up through the ranks, and they were able to champion these things that had been resisted from the top for a long time. And that was just software. We're not talking about anything as fundamental as money, right? Money's pretty fundamental. And if there's anything you should be conservative on, I understand. It's probably your money. So I think there is just, some of it is just time. Bitcoin's only been around, 15 years. That's still pretty young in terms of like large technological shifts. And, so I think, and that's deserved. Anything 15 years old, I have a 16-year-old daughter. I don't let her drive. No, not yet. Right. So, there are certain things that just.
I got my 4-year-old a motorcycle.
Wow. Okay. So there's different risk profiles. So there you go. Right. I do think that there's some understandable conservatism involved in this. There's just a general heuristic of, jumping on the latest hot tech is generally like, a poor long-term choice. And some of it is justified and some of it isn't. But I think, the direction is clear. And I think the time itself solves this. I mean, you can try to move the needle a little bit, but the main thing that's going to move it is stamina, right? Just the length of time that we consistently do good things. And this evidence piles up that it's real.
What are you looking forward to most in the next 12 months?
Yeah, it's interesting. As a tech person, when you're building the tech, it's all exciting. Once you've kind of got it working and moving, the excitement tends to happen in the layers above me, right? The usability, the layers on top, things are building, the user growth, even like political progress, all those things kind of happen up here for me. And I'm still like, hey, cool. I'm just refining the base. We've seen Lightning become the lingua franca for Bitcoin payments between different protocols, which I think will continue, and that will definitely drive things. And as some of those are, whether it be Liquid, whether it be eCash solutions, whether it be all those things, as those lift up, that naturally, there's more Lightning going around because it just ties those things together. Network effects start to kick in. You definitely see that flywheel. On Lightning specifically, I think the Bolt12 rollout continues, and we want to get recurring payments in there. One of the things that got dropped is like too much to bite off for the initial Bolt12 rollout, and it is extensible, is this idea of recurring payments. You have an offer that says, hey, pay me once a month for a subscription or whatever, and it just handles it with your wallet, handles it automatically. Gets the invoice every month, pays it, all those things. That is something that we're looking to reintroduce. There's experimental support for that in Core Lightning. Again, being experimental, when it goes through the whole spec process, it may well change. But while we took it out of the spec, we left it in the Core Lightning. It's an experimental option. I definitely want to see that rolling out because it's one of the most requested things we had from vendors is this recurring payment. Users like it too in the Lightning context because it's not a pull payment. It's not like a credit card where you got to jump through hoops to cancel it. It's literally your wallet sending the money every month. So you flip across the tab and look at your recurring payments and go, no, I'm not paying that anymore. And that's it. You're done. You are always in control of your funds. And this is that important, Bitcoin principle of, you have your sovereignty over your money. And on the Lightning level, that means that recurrence is explicit and upfront. They say, hey, you will pay me $5 a month for this service. And your wallet will handle the fact that, it requests the invoice, it gets back in a number of sats, and it checks, hey, hold on, you said you're okay with five a month, but, something's wrong with the exchange rate, right? They're asking for 6 here. Let's go back to the user and ask. Or cool, that's fine. It's within the range they've already approved. We can go do that, and it will just do it in the background. So one of the reasons, one of the things I'm looking forward to this, because I think of your wallet as your agent in the world, it should be able to do these things. But also, it's a bit of a UX lift for wallets, right? They have to have this infrastructure now that they probably haven't had to have in the past. And that does make things, it's a push. But people are pretty excited about this. And it's definitely something I want to see in 25. And just incremental improvements. There's a whole heap of technical improvements that are going on at the spec level and implementation level and everything else across Greenlight, across Core Lightning, across the other implementations and interoperability and, just improving over time. And the Bitcoin network itself, some of the peer-to-peer behavior improving, as those users kind of trickle in and it kind of goes in ebbs and flows. But if we get another flood, I feel we're going to be in a really good position to handle it. And I think that's great. But we can never tell when it's going to be. So we just have to be, keep that foundation really solid, keep iterating, and we'll be ready.
Well, that's good, Rusty. Thanks for your time today. And I look forward to talking to you for the 5th time in the not too distant future.
Excellent. Always good, Jesse. Thank you.
Thank you.